somewhere in the constellation Scutum, 15,000 light-years from where you're sitting right now, something is sending a signal. It arrives every 22 minutes. It has for decades. The signal shouldn't exist. The object sending it crossed a line long ago, a threshold where dead stars fall silent forever. And yet, it keeps calling. This is the story of GPM J1839-10. A cosmic lighthouse that refuses to go dark. In 1988, while you were living your life, something 15,000 light-years away was pulsing toward Earth. It pulsed again 22 minutes later. And again. And again. And again. Nobody noticed. The signal buried itself in archival data, hidden in magnetic tape reels and forgotten hard drives. It waited there for 33 years before anyone found it. When astronomers finally looked, they found something that violated everything they knew about physics. A dead star, still broadcasting. Impossible, and yet undeniable. Every 22 minutes, like clockwork, for at least 35 years. The signal continues right now, as you listen to this. It pulsed while you started this episode. To understand why this signal terrifies astrophysicists, you need to understand what happens when massive stars die. The explosion is only the beginning. When a star at least 8 times more massive than our Sun exhausts its fuel, it collapses. The core compresses to unimaginable density. A teaspoon would weigh billions of tons. What remains is a neutron star. A sphere perhaps 12 miles across, spinning wildly, packed with more mass than our entire Sun, dense enough to warp space-time around it. Some neutron stars become pulsars. They have intense magnetic fields that channel radiation into beams, shooting from their magnetic poles like cosmic lighthouses. As the neutron star spins, these beams sweep across the universe. If Earth happens to lie in their path, we detect a pulse. Spin, pulse, pulse. Regular as a heartbeat. But here's the catch. Pulsars slow down over time. They lose energy with every rotation. And eventually, they cross what astronomers call the death line. Below the death line, a pulsar spins too slowly to generate the electromagnetic forces needed to produce radio emissions. It goes silent. Forever. This is settled physics. The fastest pulsars spin hundreds of times per second. The slowest known pulsars spin once every few seconds. But GPM J1839-10 rotates once every 22 minutes. That's not slow. That's nearly motionless by pulsar standards. It fell below the death line long ago. It should be cold, dark, and utterly silent. And yet, every 22 minutes, it screams into the void. Powerful radio bursts that travel 15,000 light-years to reach our telescopes. The dead star speaks. The object was officially discovered in 2022, though archival searches confirmed the signal dating back to at least 1988. For 35 years, this signal repeated every 21 to 22 minutes without fail. Before many listeners were born, it was already calling. Each pulse lasts between 30 and 300 seconds. Some arrive as brief flickers. Others sustain for 5 full minutes. The pattern remains unexplained. The brightness varies dramatically, by 2 orders of magnitude between pulses. One signal might be 100 times brighter than the next. Nothing explains this variation. Astronomers describe the source as unlike anything we have seen before. It defies existing classification and challenges fundamental models of stellar physics. The signal falls far below the pulsar death line, that threshold where neutron stars should no longer produce observable radio emissions. It shouldn't be possible. GPM J1839-10 is the longest period magnetar ever detected. All other known magnetars have periods measured in seconds to minutes. This one operates on a different timescale entirely. Research teams note that its slow but steady flashing breaks the usual rules for how dead stars should behave. The engine powering it remains completely unknown. Within each pulse, scientists detected quasi-periodic substructure. Patterns within patterns, suggesting complex internal processes driving the emissions. The signal is anything but simple. The source sits 15,000 light-years away in the Scutum constellation. The signals we detect today left that dead star before the Roman Empire fell. Despite years of observation, scientists have reached no consensus on what GPM J1839-10 actually is. Every proposed explanation fails to account for all its properties. The theories attempting to explain this object read like a catalog of cosmic possibilities. Each one carries problems that scientists cannot resolve. Some propose it's an ultra-long period magnetar, a neutron star with an extremely powerful magnetic field. But magnetars below the death line shouldn't produce emissions. Others suggest a magnetic white dwarf, a smaller, less dense stellar remnant. But the signal characteristics don't match what white dwarfs produce. The spectrum is wrong. A binary system, two objects orbiting each other, could potentially explain the timing. But no evidence of a companion has been found. The source appears solitary. Some researchers quietly suggest we may be looking at an entirely new class of cosmic object. Something we've never encountered before. Something that requires new physics to understand. GPM J1839-10 is not alone. It belongs to an emerging category of long-period radio transients. But only a handful have ever been detected. These long-period transients challenge decades of pulsar theory. Their very existence suggests our models of neutron star physics are incomplete. Perhaps fundamentally wrong. Consider the implications. For decades, we believed we understood the death of stars. We had equations. We had models. We had certainty. A single object, pulsing in the darkness 15,000 light-years away, has called that certainty into question. What else have we gotten wrong? The signal continues to this day. Telescopes around the world monitor GPM J1839-10, recording each pulse, measuring each variation, searching for patterns. Research published in 2023 confirmed the object's unprecedented properties and noted unusual emission features that defy easy categorization. Every 22 minutes, like a heartbeat in the void, the dead star sends its signal across 15 millennia of empty space. And we have no idea why. Think about what that means. Something that should be silent is speaking. Something that should be dead is alive. Or at least, doing a convincing impression of life. The universe is not obligated to make sense to us. It operates on rules we're still learning. And sometimes, it sends signals we cannot explain. The light, the radio waves, reaching Earth today left GPM J1839-10 15,000 years ago. We're seeing the ancient past, still pulsing, still signaling. When those signals began their journey to Earth, humans were painting on cave walls. Mammoths still walked. Civilization was 10,000 years in the future, and yet the signal arrives with mechanical precision. Every 22 minutes, without fail. Across all those millennia, it kept pulsing. It kept calling. What can we take from this? Perhaps humility. We've mapped the cosmos with equations and observations. We believed we understood the death of stars. We were wrong. The universe contains phenomena that mock our understanding. Objects that shouldn't exist, doing things they shouldn't do, with mechanisms we can't explain. For 35 years, something has been pulsing toward Earth with mechanical precision. Before you were aware of it, It was already sending signals in your direction. You can choose what to make of that. Some find it terrifying. The idea of an unexplained signal calling from the dark. Others find it beautiful. Tonight, if you look toward the constellation Scutum in the summer sky, you're looking toward GPM J1839-10. You can't see it with your eyes. But it's there, and in approximately 22 minutes from whenever you're listening, it will pulse again. It always does. It has for longer than you've been alive. Scientists will continue studying this object. They'll gather more data, propose more theories, argue about mechanisms. Maybe someday they'll understand it, or maybe GPM J1839-10 will remain unexplained. A reminder that the universe keeps secrets from us, that some lighthouses shine for reasons we'll never know. There's something unsettling about a signal with no explanation. We want the universe to make sense. We want patterns we can understand, causes we can identify. GPM J1839-10 refuses to cooperate. It sits below the death line, pulsing anyway. It varies its brightness by factors of 100, for no apparent reason. It contains substructures within its pulses, patterns within patterns, suggesting something complex happening inside, but we don't know what that something is. The 22-minute periodicity is remarkably stable. Unlike many variable cosmic sources, GPM J1839-10 keeps nearly perfect time, like a clock that refuses to stop. Consider that precision. Across 35 years of observation, through whatever cosmic events have occurred, the signal maintains its rhythm, unwavering, mechanical, inevitable. What keeps that clock ticking? What engine drives a dead star to pulse with such regularity? The answer might rewrite textbooks, or it might remain forever unknown. We live in a universe filled with mystery. Most of it we'll never encounter directly, but this signal, this impossible pulse, reaches across 15,000 light-years to touch our world. It doesn't care if we understand it. It doesn't require our comprehension. It simply pulses, and pulses, and pulses again, faithful to its own rhythm. Perhaps the deepest lesson is acceptance. The cosmos operates beyond human understanding. We can observe, we can measure, we can theorize, but we cannot demand explanations. If this story lingers with you, let it. Let the strangeness settle. A dead star, 15,000 light-years away, breaking the rules of physics, calling toward Earth. You don't need to understand it to feel its weight. Some mysteries are valuable precisely because they remain mysterious. They remind us how small we are. The signal continues. Right now, as you finish listening, radio telescopes around the world are detecting its latest pulse. 22 minutes from now, they'll detect another. GPM J1839-10 has been calling since before you were born. It will likely continue long after you're gone, a lighthouse in the void, keeping its own counsel. Somewhere in the constellation Scutum, something impossible keeps pulsing. And we still don't know why. Maybe we never will. Sweet dreams.